Hello, my name is James Westbrooks, a member of the team GT Sons of Andreas, along with Chris Maple, Nick Randall, and Andreas Ward, and this is our presentation on the evaluation report for the final design project. In true spirit of classic British comedy, Terry Gilliam's 1975 film Monty Python and the Holy Grail is this year's theme for the Emmy 2110 final project. Iconic scenes as seen before you, including King Arthur's famous battle with the Black Knight, the uncasing of the holy hand grenades of Antioch, and the shrubbery debate with the knights who say "Ni" have been transformed into the ultimate mechanical engineering design competition. Here is a layout of the competition. Teams will construct machines to be placed on the combat arena and will be pitted against each other, trying to complete tasks inspired from scenes in the movie. The tasks include defeating the Black Knight, or removing the black dog bone seen in the figure from the team zone, collecting shrubbery, or pulling in tennis balls that line the respective zones, delivering the holy hand grenades of Antioch, or placing ping pong balls inside the rotating cylinder that is the beast's lair, and ultimately retrieving the Holy Grail. Now perhaps it would be easy if the machines only had to worry about one task, but that brings us to the first problem of multifunctionality. Machines have 4 unique tasks to perform, and designing the machine to accomplish them all in a swift manner is certainly a challenge. This forces the proper allocation of resources and time per task, which means major prioritization. Finally, restrictions on the size of the machine and limited power sources will make things challenging, not to mention the limited time as the final competition is only weeks away. Of course, the overarching goal is to create the winning robot for the competition on November 11th, which will be done through capturing the points as seen in the table before you. Now, there are hundreds of ways to accomplish the task for the project and ultimately achieve those points, but we've outlined 5 different designs that have the best chance of success. So let's take a look. If you remember from last time, shown before you is the morphological chart that outlined different solutions for each subsystem. This was a great stepping stone for our 3D CAD models, which you will see in a second, but it's important to note this is where the working models came from. Features like retrieving the Black Knight out of the zone, the drawer slides pushing the arms for the shrubbery, and rolling grenades down pipe arms all make an appearance in our final design. As for each design, in true GT Sons of Andreas fashion, each concept is named after a character from the Grand Theft Auto San Andreas video game. In addition, for all CAD models, blue-colored subsystems show lobbing the hand grenades, red is defeating the Black Knight, green is collecting shrubbery, and yellow is retrieving the Holy Grail. Seen before you is Jizzy B, named after the most famous pimp in all of Grand Theft Auto. Jizzy B features 2 double-hinged arms with rotating casters for collecting shrubbery, a drawer slide system with a PVC pipe and rotational spinner, and a Holy Grail retrieval arm that extends from the drawer slide, and a Black Knight removal system. The beauty in this design is that it is initiated by a single actuator, and every subsystem runs upon the drawer slide's initial movement. The only downside to Jizzy B is that the motors that pull the shrubbery arms back tend to tangle a string, so if this design is chosen, a better string wrapping mechanism would be necessary. The next design is the Truth. The Truth's main features are its 2 hinge shrubbery arms, drawer slide and PVC pipe for delivering grenades, and battering ram for retrieving the Holy Grail. Its advantages is that it has separate subsystems, so if one does not work, the others are still available to function as intended. The main disadvantage to this design is the Holy Grail battering ram largely runs on chance, and could lead to disqualification if the plastic breaks. The next design is Mad Dog, a solenoid-activated machine that consists of similar shrubbery arms in regards to the other machines, but has an interesting design in terms of the Grail Grabber and Grenade Distributor. The Grail Grabber has a mousetrap that is activated upon launch, which brings it up to the Grail height, where it ultimately can grasp onto the plastic and pull it into the zone. The Grenade Distributor differs from the traditional spinner, as instead of rotating, it simply hinges back and forth to place balls inside the beast's lair. The advantage of this design is that it all runs from a single system, the activation of the drawer slide. The disadvantage is that it does not have an actuator powering it, which means there's a huge loss of speed in terms of how quickly tasks can be accomplished. The next design is Big Bear, which is very similar to the Truth design as seen earlier, as it features hinged arms for collecting shrubbery, a single drawer slide system, and a double hinge system for pushing the Black Knight out. The difference with this design is that it features its own unique drawer slider specifically catered towards retrieving the Holy Grail. Its advantage is that it allows a lot of space on the base of the machine, but its prioritization of the Holy Grail puts a high value on a low probability task. The final design is OG Loke, a single drawer slide based machine that attaches the Black Knight removal system to the shrubbery arm and allows for a mousetrap to slap the dog bone out of the arena. Since the bone is removed immediately after the arms touch the ground, the machine can collect shrubs without any interference from the other components. After compiling the results from these designs, the evaluation matrix as seen before you was created. It is obvious that Jizzy Bee has the highest point total, but by taking a closer look at their comparison with the customer requirements, one can get a better analysis. Because of its compact nature and strong drawer slide connections, Jizzy Bee receives high scores in robustness and portability. Its consistency across all tasks also accounted for its high point total, as other machines tend to focus heavily on a single task. Thanks for watching, and we look forward to checking in with you next week.